Guys, I got another request from SN, right? So today we're going to discuss problem D from Codeforces Global Round 6, alright? As always, we introduce this problem by explaining the examples, alright? So what we have here is 3. 3 is the number of people in the graph, right? 1, 2, 3. And 2 is the number of edges in the graph. The first one means people, the second people here lend $10 to the first person, right? And the second edge means the third person lent $5 to the second person, right? So what's the output is about? It's the same, right? It's also a lending graph. So the second person lends $5 to the first person, and the third person lends $5 to the first person, right? So the output, what's the commentary between these two graphs? As we can see, the second person in the first graph, it gets $5 and lends $10, right? So in total, he lends $5, right? And the first person here gets $10. So overall, he gets $10. And the third person overall lends $5, right? Same in the output, right? The first person overall gets $10. And the second person lends $5. And the third person lends $5. So what we need to do is to make sure that we transform this graph into another graph that in the output, the total number of edges, I mean the total value of all the edges should be minimal. It doesn't matter how many edges are there. What matters is that the total value of those edges should be minimal, right? So in this graph, the total value of the edges is 10. And in this graph is 15, right? So this one is the minimal. So let's look at another example, right? So the second person lends $10 to the first person, right? The third person lends $15 to the second person, right? And the first person lends $10 to the third person, right? So how do we simplify this graph? So this is the simplified version, right? Only the third person needs to lend $5 to the second person, so that this guy, the third person, in total lends out $5, right? Because he lends out 15 and gets 10, so in total he lends $5. Same in this graph, right? And for the second person, in total, he gets $5, right? And the first person, nothing here, right? So as we can see, the thing that matters is the final balance of each person, right? For example, this guy's final balance is -5, and this guy's final balance is +5, and this guy is 0, right? We just need to make sure that in the final graph, the final balance of each person are the same as the initial graph, right? How do we make sure of that? So first, we get all the edges in the graph, and then based on the edges, we can calculate each person's balance, right? We can calculate the first person's balance is 0, the second is +5, and the third is -5, right? We can calculate each person's balance, and then we have two queues, right? The first queues are the persons have positive balance, right? And the second queue are the people that have negative balance, right? We just need to ignore the people has balance of 0, because we don't need to do anything to those person, right? So when we got all the people that have positive balance, we can just choose one people from the negative queue and just connect them, right, with edges, right? For example, in this case, the positive person is the second person, right? And we just randomly choose one people in the negative queue. In this case, the person we get is the third person, and we connect them, and we land from the negative person to the positive person, right? So in this way, we can get a minimal graph, right? So let's look at the code. At first, we just read n and m, right? And then we calculate the balance, right? The number stored in the total array is the balance of each node, right? And then we get two queues, right? One is positive queue, one is negative queue, right? Based on their balance, right? Then we sort them. I'll explain later why we need to sort it, right? Why we need to sort these two queues. Okay, I'll pin a stick there. Let's move on. In this part, we in each step we get a minimal number from current point to the positive numbers, and pointer to the negative counters, and get the smaller one, and that is the amount of money we need to land from the positive to the negative person, right? Then we do it by add a new transaction in the answer, right? And then we move the pointers, right? After we finish all the steps, we can make sure that in the final graph the balance of all the people are the same as the initial graph, right? Then we output all the transactions, right? So why do we sort here? The reason we sort is because in the worst case, let's say a big lender here, he lends like $100, and some small lenders there. These are all the people in the negative queue, right? And there is some small positive borrower in the queue, right? And there is a big borrower in the queue. If we don't sort these two queues, we may end up with these guys borrow money from this guy, and these guys borrow money from this guy, right? That is a lot of transactions. Instead, if we just lend money from this guy to this guy, and those small guys lend money to each other, that is lesser number of transactions, right? In this case, we can save a lot of transactions in the end result, right? So we won't get a memory error when we run the algorithm, right? I guess that's it for today. Thank you for watching.